Welcome to the lesson on Law of Gravitation. We will be able to explain Keplers Laws of planetary motion, explain gravitation, state the universal law of gravitation and explain its importance, calculate the acceleration due to the gravity on Earth, differentiate between mass and weight.
This picture, it shows all the planets are revolving around the Sun.
Yes, Tina, and you see, this is the picture of Johannes Keplers. In early 16th century, he explained that all the planets revolve around the Sun in elongated orbits rather than perfect circles. Based on these observations, he derived 3 laws which govern the motion of planets. These are called Keplers Laws.
It sounds very interesting. Please explain me in detail.
As per Kepler's law, there are 3 laws of planetary motion: the law of orbits, the law of areas, and the law of periods. Kepler's first law states that the orbit of a planet is an ellipse with the Sun at one of the foci. An ellipse is a closed, curved shape that is defined by 2 points called foci. The sum of the distance from a given point on the ellipse to the foci is always constant. The distance of the Earth from the Sun is not constant. When the Earth comes closest to the Sun, then that point of Earth's orbit is called perihelion. The point on the Earth's orbit when the Earth is farthest from the Sun is called aphelion. At perihelion, the Earth receives maximum heat from the Sun. Hence, we experience a hot season. At aphelion, being far from the Sun, the Earth receives lesser heat. Hence, we experience winter season. Kepler's second law states that the line joining the planet and the Sun sweep equal areas in equal intervals of time. That means if Earth sweeps the area between A and B in 20 days, and again it sweeps another area between C and D in 20 days, then both the areas are equal. Kepler's third law states that the cube of the mean distance of a planet from the Sun is proportional to the square of its orbital period t. Orbital period is the time taken by the planet to make a complete revolution around the Sun along its orbit. Here t is the orbital period of the planet in Earth years, while r is the mean distance in astronomical unit. 1 astronomical unit is equal to 150 million kilometers. What are you thinking about?
Dad, I am thinking that why do all objects fall downwards when they are thrown up?
This is because the Earth has got a gravitation force that attracts the objects towards it. Do you know the reason behind the revolution of Moon around the Earth?
No, Dad.
It is said that when Newton was sitting under a tree, an apple fell on him. He started thinking that if Earth can attract apple, then why it cannot attract the Moon?
What happened next?
Newton concluded that each point on its orbit, the Moon falls towards the Earth instead of going off in a straight line.
But Dad, we don't really see the Moon falling towards the Earth.
Tina, for better understanding, let's understand a game called hammer throw. Here, the athlete swings a hammer around and releases it at certain point, such that the hammer flies in a certain direction. The hammer moves in a circular path, with certain speed and changes direction at every point. The force which causes body to move along the circular path always acts towards the center. This force is called centripetal force. The centripetal force is provided by the force of attraction of the earth. When the hammer is thrown, it flies off along a straight line, tangent to the circular path. Similarly, motion of moon around the earth is due to centripetal force. If there were no such force, the moon would move in a uniform straight line motion.
Dad, is this force also responsible for the movement of planets around the sun?
Yes, there exists a force between the sun and the planets, same as the force between an apple and earth, or earth and the moon. This force of attraction between objects is called gravitational force. About universal law of gravitation. According to this law, every object in the universe attracts every other object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. The gravitational force is along the line joining the centers of two objects. To derive the expression for universal law of gravitation, let us consider two objects, A and B, of masses m1 and m2, which lie at a distance d from each other. Let the force of attraction between two objects be F. According to the universal law of gravitation, the force between two objects is directly proportional to the product of their masses, and the force between two objects is inversely proportional to the square of the distance between them. Combining both the equations, we get F proportional to m1 m2 divided by d square. To equate this equation, we use a constant of proportionality, g, which is called the universal gravitation constant. We can get the value of g as fd square divided by m1 m2. The SI unit of g is Newton meter square per kilogram square. Henry Cavendish found the value of g by using a sensitive balance.
Importance of this law.
The universal law of gravitation explained several phenomena like the force that binds us to the earth, the motion of the moon around the earth, the motion of planets around the sun, the occurrence of the tides due to the motion of the moon and the sun. Of free fall, Tina?
Not actually.
We already saw that when a ball is thrown up, it falls back to the earth. If this rock is pushed from a height, it falls to the earth. This is called free fall. An object is in free fall when it falls to the earth under the sole influence of gravity.
What if an object is thrown from a hot bag? Is it a free fall?
Yes, it is a free fall because there is no change in the direction of motion of the object. But velocity of the falling object changes due to the Earth's attraction.
How is that caused?
Whenever an object falls towards the Earth, acceleration is involved. This acceleration is due to the Earth's gravitational force. This acceleration is called the acceleration due to the gravitational force of the Earth, or acceleration due to gravity. It is denoted by small letter g. The unit of g is the same as that of acceleration, that is meter per second square. Tell me, how will you determine how long it will take a free-falling object to reach the Earth's surface from a specific height?
To calculate the time taken, I need to know the acceleration due to gravity.
Yes, you are correct. Let us derive an expression for acceleration due to gravity. From the second law of motion, we know that the force is the product of mass and acceleration. Let the mass of the object be small m. We know that the acceleration in the falling object is due to acceleration due to gravity g. Hence, F is equal to mg. Let this be equation 1. Let capital M be the mass of the Earth. Let d be the distance between the object and the center of the Earth. Let r be the radius of the Earth. The gravitational force F can also be calculated by Newton's universal law of gravitation, which is equal to g into m and m divided by d square. When the object is near to or on the surface of the Earth, distance d is taken to be equal to radius of the Earth. Equating equation 1 and 2, we get acceleration due to gravity is equal to g multiplied by m upon r square. The Earth is not a perfect sphere. As the radius of the Earth increases from the poles to the equator, the value of g becomes greater at the poles than at the equator. For most calculations, we can take g to be more or less constant on or near the Earth. Acceleration due to gravity, we need to substitute the value of g, mass of the Earth, and radius of the Earth. Upon substitution, we get the value of acceleration due to gravity of the Earth as 9.8 meter per second square.
All objects fall from the height at same rate?
Actually, all objects, hollow or solid, big or small, fall at the same rate. The equation of acceleration due to gravity is independent of the mass of the object.
But Dad, some object like paper falls slower than stone if thrown from the same height. Why is that?
The air offers resistance due to friction to the motion of falling objects. This resistance is more to paper than stone. Therefore, the rate of fall varies. As g is constant near the Earth, all the equations for the uniformly accelerated motion of object become valid with acceleration a replaced by g. Here, u and v are the initial and final velocities, and s is the distance covered in time t. In applying these equations, we take acceleration to be positive when it is in the direction of motion. Accelerations will be negative when it opposes the motion.
And weight, two different things?
Yes, mass and weight differ in many ways. Mass is the measure of matter in a body. It remains the same whether the object is on Earth, the Moon, or even in outer space. Thus, the mass of an object is constant and does not change from place to place. On the other hand, weight is the force with which a body is pulled towards the center of the Earth. It is equal to mass into acceleration due to gravity. SI unit of mass is kilogram, while SI unit of weight is Newton. Mass has only magnitude, while weight is a force acting vertically downwards, so it has both magnitude and direction.
Since weight of an object changes with location, will a person weigh more or less in moon?
The weight of an object on the earth is the force with which the earth attracts the object. Similarly, the weight of an object on the moon is the force with which the moon attracts that object. Since the weight of the moon is lesser than the earth, hence weight of an object on moon will be lesser. Of the object on the moon. Mass of the moon is 7.35 multiplied by 10 raised to the power 22 kilogram. Radius of moon is 1.74 multiplied by 10 raised to the power 6 meters. Mass of earth is 5.97 multiplied by 10 raised to the power 24 kilogram. Radius of earth is 6.37 multiplied by 10 raised to the power 6 meters. Let mass of the object be m. Using universal law of gravitation, force of gravitation is equal to gmm upon d square. Weight of the object on the earth is 2.43 multiplied by 10 raised to the power 10 gm. Similarly, weight of the object on the moon can be calculated as 1.47 multiplied by 10 raised to the power 11 gm. Upon finding the ratio of these two weights, we get ratio as 1/6. Hence, weight of the object on the moon is 1/6 of its weight on the earth.